Hitesh, can you mute your mic?
Welcome everyone to our first Magma 5G Ask Me Anything session. We're really glad to have this and see we have a pretty good group of people. I see that there's about 40 people on the bridge. So that was going to make for a really good discussion this morning, I hope. Cotter is going to kick us off in just a minute, but before we do that, I would like to just take a minute to remind everyone that we do have a large bridge this morning, and if you could help us out with good bridge courtesy and keep your mic muted unless you do need to speak up. We do want this to be interactive, so during our presentations, if you want to jump in immediately, please feel free to do that, but we do have about a quarter of our time at the tail dedicated to Q&A, and perhaps holding questions to that session might let the flow of the morning go a little bit better. Apologies in advance if we have any technical issues. At least one of our presenters is in India, quite a long way away, and he has a video to present, and we may have to do some quick shifting to make sure that we get that done effectively, but I think that's going to work out okay. So without further ado, Cotter.
Thank you very much, Phil. Again, good morning, everyone, and welcome all of you for the Magma community meeting. We call it as Magma 5G, everything you need to know. So from my point of view, the secret to the success of any community is the people. And you all joining this call today is the proof of this great people-led grassroots Magma community. Thank you once again for taking time to support us with this great initiative. My name is Kader Khan, Senior Vice President at Wave Labs, and joining me is Phil Ritter. We all know him. He's famous and requires no introduction from Facebook and Magma Core Foundation, will be your hosts. Phil, do you want to say any words, please?
I think only to deny being famous, but thank you for your kind introduction.
Thank you very much. Let's get started with understanding why are we here and why are we having this meeting. I mean, to me, there is no brainer. It's obvious that it's a great opportunity for each one of us, knowing 5G private network projects have doubled in past year. I mean, there are a lot of research firms, undoubtedly experts, research analysts, and firms foresee high growth in this segment. For example, the recent research from ABI Research predicts the growth of US 75 billion by 2030. So the other data point I also would like to highlight is that after Magma Core Foundation was formed early this year, we have seen rise in adoption of Magma 5G in both community projects such as Linux Foundation 5G Super Blueprint and commercial 5G projects among vendors and network operators and service providers. So having discussed with stakeholders at Magma community, we are convinced that we require a dedicated platform, meeting and support for enabling engagement, collaboration and adoption of Magma for 5G. So we are structured and starting with the 3 key objectives of this monthly recurring meeting. The first one is we want to ensure community has a good understanding of ongoing and future 5G development activities. And the second one is we want to ensure we help enabling collaboration and alignment with cross-community 5G project initiatives. And finally, we wanted to get support from community to assist you both other community projects as well as commercial projects with demos, integrations, support, and so on. Like I said, we are starting with these 3 key objectives because we're just starting now. But depending upon your feedback and inputs, we are flexible to act and adapt the objectives in the future. So today's agenda, today's program, we kept it pretty basic because this is the first session and first community meeting for 5G, dedicated for 5G. Welcoming pretty much, we are through with it. Next, Rajesh will share his insight about 5G market trends, followed by Phil, who will introduce Magma for 5G and also the roadmap. Then Suresh and Parthiban will talk about current feature support, quick demo, and 5G community support structure that is in place to help you all. And finally, we will end with Q&A, next meeting plan, inputs from you all, and close the session. So with that, I would like to welcome Rajesh to take it away. Rajesh, do you want to share the floor?
Sure, yeah. Can I share my screen?
Yes.
Presentation.
I stopped sharing for you, Rajesh.
Great. I hope you can see my screen. And thank you, Kader, for the introductions. So my name is Rajesh Rasakar. I'm a part of the Facebook connectivity team. I am a system architect at Facebook Connectivity. And I'm also a co-lead for a TIP project on the RAN orchestration and automation. So I'm going to spend maybe 10 minutes or maybe maybe a little bit more than 10 minutes to talk about the 5G use case and also talk about how we are seeing the 5G ecosystem. What are our views on the industry and geographic trend towards like hottest technologies across AR, VR, autonomous vehicle, industrial IoT, cloud gaming, and we can observe basically one common factor, that is the connectivity here, correct? So connectivity is the backbone of many of the today's most technology, and it will become a more important due to the adoption of the 5G and also the towards the 6G. So before we jump into the importance of Magma and its architecture benefits and also the open RAN technologies, correct, from the TIP point of view, I think it is important to spend some time on why there is a need for 5G and why there is architecture change that is happening towards the 5G core, and what are the use cases driving such change, correct? So we need to go back and study more like ITU requirements for IMT, which is the International Mobile Telecommunication Body. The objective of the ITU is to provide like vision for IMT to address the need for mobile services for 2020 and beyond, by describing the potential use case, application trend, the growth in traffic, uh, and also the spectrum implications, correct? And what we see, like what industry is saying, there are 3 major use cases here. One is the enhanced mobile broadband, where I think the device or the use case needs a data speed in gigabits per second. Specifically, you can expect like the downlink peak data rate up to be like 20 gigabits per second, while the uplink on 10 gigabits per second. We'll talk about how the network, like the 5G network convergence with 5G and Wi-Fi, which is maybe the important topic for the 5G deployment, as you can see from the next few slides. The next use case is also the ultra reliable low latency communications. This is required for like mission critical services such as like augmented, the virtual reality, telesurgery or healthcare, like intelligent transportation, industrial automation, and also the robotics and factory automation. But I think for when you talk about ultra reliable low latency, we are looking like latency, the user plane latency around like 1 milliseconds, while the control plane latency can be 10 or 20 milliseconds, which is very important for like the IoT use case, or maybe for some other remote surgery or other use case. I think the way you achieve like this low latency, again, I think Phil will talk about like the disaggregation of the control and signaling from the Magma point of view, and how the Magma with local breakout, where we can put user plane functions to be very close to the user or close to the application where you want to break out the session. And the third use case here, you can see it is the massive IoT, correct? That we are seeing like big, like we are seeing like billions of connection with range of different devices, different capabilities. They want to connect to the internet, and I think there's so many use cases around the massive IoT. Again, I will not talk about those use cases, but I think you can see from the industry point of view that there is a shift happening for the 5G. And one of the big concepts for I think IoT is also the network slicing. The network slicing basically provides a way of like for service provider to enable like network as a service to enterprise, so that it gives a flexibility to manage their own services or own devices on the 5G network. And I think the good news is that I think Magma has the network slicing as part of the roadmap. So while there is a push for 5G, and you can see the telcos as a primary provider. I mean, they should be taking the advantage of 5G, and also technology changes happening towards the 5G. But I think on contrary to the expectation, we have observed like many telcos are struggling to perform despite these industry changes, correct? So some of the factors that one of the area that I think the concerning is like the data consumption is going up. There are many devices are coming online. The user traffic, I think everyone wants higher throughput. The data consumption is increasing, and to support data consumption, we need like the 5G, we need a spectrum, we need the cloud computing. There are a lot of technologies that needs to happen, where I think operator needs to spend a lot of capex. And that is creating a problem, correct? Because I think if you look at the industry trend, the ARPU is going down. It's not going up actually. So you expect that if the data consumption goes up, I think ARPU should basically follow that the path. But I think in contrary, the ARPU is going down. So that's create a challenge for the operator. And I think and if you see the OpEx point of view, again, this is a little bit old slide, but OpEx is it's basically it's the same, correct? So you still need people, you still need technologies to maintain the network, to operate the network. And I think with all open source technologies and everything coming in, the OpEx the OpEx cost might go up, and eventually it will go down. But I think the OpEx will remain constant, so it's not changing drastically from the operator point of view. So these are some of the challenges, and I think this is why the Magma is an open source core, and also the other initiatives such as that we see like Open RAN from the tip point of view. Those are very important technologies so that to enable the 5G technologies. Again, I'll not talk about the Open RAN, and here I think our focus is on the Magma and on the core side. But I think on the RAN side, we are already seeing the distributed RAN functions. We are already seeing as part of the ORAN initiative, where they talk about the CUDU disaggregation from the hardware. We talk about the cloud native application, not just for the core, but also from the RAN point of view. So I'm going to skip the slides. I know I only few more minutes to cover like the few other slides, more on the core side. But I think if you look at the basically from the core point of view, there is also shift happening from the traditional 4G core, LTE core, the EPC packet core towards the 5G. The 5G is basically talking about SPA, service-based architecture. And I think, and if you look at traditional the 4G architecture, the 4G architecture was more like a reference-based architecture, where there is an individual interface where when you talk about MME to the HSAs or MME to S gateway, serving gateway, or PDN gateway to PCRA, there is a reference interface where if you create one network elements, you need to create links, and mostly it's a diameter based links. So I think that's created some complication in terms of operation or also in terms of deployment. So what 5G core brings is more like a reference based architecture. Not reference-based architecture, more like service-based architecture, where the network is driving based on the services. So instead of having the interface links like such as the diameter, you just create this service bus where all these network elements, which are like AMF, SMF, UPF, NRF, NESF, NEF, and SSF functions. You don't need dedicated like reference interface. While you just create a service-based architecture, which can be part of the RESTful APIs, and you just basically create interfaces. And the 5G brings one of the component, which is NRF, network repository functions, which maintains the information about the instances. So if you see traditional, that there used to be DNS for the node selection, that architecture is going away by towards SPA architecture. I'm sure I think Phil will cover like the importance of the Magma and the Magma 5G core architecture from the service-based architecture point of view. And one of the important things, maybe I'll spend 1 or 2 minutes here. We are seeing that the various deployment options. So I think we have seen like NSA, the non-standalone option for 5G deployment, where you have two technologies working simultaneously, both on the 4G RAN, also the 5G RAN, and based on the operator use case or based on the operator's desire to offer services, the E node B or the G node B, the 5G G node B, it can act as a master. It can as the serving node. So I think the option 3x, which is very common option for deployment of the 5G on existing the 4Gs on the packet core, also basically anchoring the 4G RAN as anchor points towards signaling interface to a packet core. We also see like there is a big shift happening towards 5G SA architecture, the standalone architecture, which is option 2. We have seen a lot of deployments, mostly are on the fixed wireless access, which is very popular use case for the SA like option 2. We also see the private the 5G deployment, which will also be based on the option 2. Again, I think it depends on the operator. Again, there are some certain challenges in terms of maintaining the network, maintaining the spectrum. But I think what we see is more like option 3 for NSA and option 2 for SA as a popular choice of the deployment. I think I'm going to skip a couple of slides because I want to hand over the floor to Phil. I'm sure I think the Phil will talk about network slicing, but I think if you look at high level, like network slicing is a concept of slicing the network, whether it's part of the logical network or whether it's a physical network. Its idea is basically create a multi-dimensional view of the network where you can serve the same network for multiple use cases. That one of the use case that we see, there is a big driver for network slicing. There is also conversion happening with non-3GPP access, where I think again, I think with the 5G standalone option is a good option if you're really a greenfield deployment. But I think if you really want to take advantage of multi-access technologies, I think there is a convergence happening from the core point of view, where the core can support multiple access technologies, not just the 5G RAN, but also the Wi-Fi or non-3GPP access. And also the interworking, when you talk about the 5G SA deployment, you still have to support the 4G, correct? So your 4G network will not go away unless there is a fixed wireless use case where you don't have to interwork with the 4G. But in traditionally, I think you may want to have interworking functions that needs to interwork between the 5G core and also the 4G core. I think the standard is looking for N26 interface if you are really doing the interworking function. And also it might be an important activity if the operator needs to support voice over 5G NR, the voice services, correct? So I think there are many operators who has started the journey of voice from the traditional circuit switch domain towards voice over LTE, which is IP-based voice delivery. And when you talk about the 5G, I think the 5G will only support the IP-based voice. They will not support circuit switch fallback the way the traditional the 4G has supported, where I think the voice could be offered on the circuit switch domain while the data can be still carried on the 4G network. But in 5G, I think all the traffic, whether it's voice or data, will be transmitted over the 5G network. And I think that's why it's important to think like when you deploy the services, the voices will remain the critical path, at least for the service provider point of view. It may not be critical for the private networks, but it is very important aspects from the service provider point of view. And I'm going to, I took more than 10 minutes, so I'm going to stop here. And I'll maybe if you have any questions now, or if you want to wait till the presentation is over, it's up to you.
Thank you, Rajesh.
I'm going to hand over this floor to.
Thank you, Rajesh. We'll take the questions towards the end, with the interest of time. Phil, I think you are on pressure because Rajesh took a little bit more of your time, so please take it away.
Oh, no worries. Rajesh, could you pull down your share? Thank you. So I'm just going to talk this morning at a very high level about Magma. I don't think that I'll be able to get into the level of detail Rajesh suggested, given the time that we have and the focus of this morning's meeting. But I wanted to make sure that we had a chance to introduce Magma to this group and talk about it in this context. First and foremost, I want to talk about Magma's mission. Why we're doing this. The Magma team, the Magma Core Foundation, exists to help connect the world to a faster internet by enabling providers to build cost-effective, extensible, carrier-grade networks. And that goal is served by developing open source products designed in a way to help lower the total cost of ownership of wireless networks or the wireless network core, and especially focusing on implementations that can be carried out in places that are traditionally unserved or underserved communities because they have not picked up the interest of the major carriers and don't provide an opportunity for the kind of revenue that it takes for those carriers to support their business. With that, we also have found that there are associated opportunities, especially around private network services and as we develop 5G, private 5G services. So Magma is a combined architecture that focuses on the core of the core. And in the services-based architecture drawing that Rajesh put up, the elements that actually manage the radio network directly are the AMF, the SMF, and the UPF element. And Magma takes those three elements and combines them together into an access gateway architecture that is designed to be lightweight, that can run on very small hardware platforms. It's intended to be distributed near the network edge and scaled horizontally. So rather than building a huge access gateway in a central point to serve thousands of eNode Bs or gNode Bs, rather the focus is to deploy multiple smaller access gateway nodes that are deployed around near small handfuls of radio sites, 10, 5, even embedding the core into a single access gateway node as a combined platform. Magma is designed to be an all-access design. Its heritage is around LTE. It includes integration of Wi-Fi services, and it's being expanded now to support 5G services. It's deployed in three primary components. First is the access gateway itself, which in the LTE instance includes the MME, SGW, PGW. In the 5G implementation, it includes the AMF, SMF, UPF. In both cases, it includes elements of policy enforcement, simple extensions of policy enforcement. And then for Wi-Fi, managed Wi-Fi services, it includes a AAA and the access gateway integration so that it can all be built on a single substrate design that, again, is very lightweight. It can be deployed on simple 4-core fanless, very, very small elements that can be placed near the radio sites. Additionally, Magma comes with a network management function. Magma's legacy named that the orchestrator, but as the industry has evolved, the common understanding of an orchestrator is something much bigger that orchestrates the entire network. In the NFV nomenclature, this is more the element management function or the management of the gateway itself, and providing REST APIs that can be integrated with a higher level orchestrator, such as ONAP is a great example with a sister project, also from LF Networking. And then finally, because Magma internally implements its own gRPC-based communication between the functions of the access gateway, we include a federation gateway, which provides standard 3GPP interfaces to other elements in a larger network. These are both the traditional diameter-based interfaces you might see to the legacy PCRF or OCS, HSS, for subscriber and policy and charging management, and also the service bus interfaces that are described as part of the 5G services-based architecture. Internally, Magma is constructed in a partially decomposed software-defined networking architecture with the bearer plane functions of pipeline D being implemented with Open vSwitch, or a control plane for Open vSwitch underneath. And then session management and the other management of subscribers and policy are all implemented as independent services that are interconnected by gRPC-based API interfaces. And all of these interfaces are published as protobuf specifications in our open source code. So it's easy relatively easy to extend them or make modifications to Magma. And this substrate, this SDN substrate of Magma, is common, whether you're using 4G services, 5G services, managed Wi-Fi services, in the future, any other potential radio deployment that is architecturally similar to the 3GPP infrastructure. This can be common and carried forward. And we're actually quite proud of the simplicity that this brings to the Magma core. So for 5G, we've added the 5G services that functionally perform the AMF and SMF functions. And the UPF function is actually self-contained within the SDN control through pipeline D. So it's a very extensible architecture. I also want to talk briefly about how we choose what features to implement. Many of you are probably familiar with 3GPP's library of requirements and capabilities, and it is huge. And realistically, if you look across the spectrum of implementations, even the largest traditional network equipment providers don't ever implement everything that's specified. The Magma team has taken a minimalist approach, which is let's pull back and only implement what is actually necessary for live deployments of end user with end user needs that we can trace to it. So we don't typically go in and say we're going to implement all of 3GPP release 15 and the entire suite of things, but we'll look to specific customer deployments or user deployments and demand for features and capabilities to build what is needed. On top of that, we're working a rapid iteration model with an agile development process within the foundation, so that when features are identified, they can be integrated reasonably quickly. And then a software delivery model that allows you to do reasonably hitless or simple deployments once you do have upgrades, especially for the orchestrator and the access gateway, which are much more likely to be updated. So with that, we really look to what is realistically needed by a user to deploy a fixed wireless access deployment. And fixed wireless access is typically not heavily dependent on handoff. So a lot of the handoff related features may have been deferred, or a private 5G deployment which needs local handoff among the nodes of an access gateway, but not global handoff to third-party networks, at least not immediately. And in this way, we're able to ladder in features reasonably into the deployment. Our 5G roadmap, internally, we have actually completed the baseline deployment of 5G service. We're able to register, deregister 5G mobiles, do simple authentication, idle mode, paging, and carry traffic on the 5G network. We're in the process of finishing up and cleaning up a number of features that we're targeting into Q3 to really make it a functional 5G deployment with QoS and some extensions to subscriber data management within the platform. And then continuing to add in additional features that would be needed to support larger and larger networks, including hardening and scale testing and proof points and enhanced charging and usage reporting. And then we're working to provide parity with our 4G fixed wireless access implementation of Magma. So testing and proof that anything we can do on a 4G network with Magma, we can do with a 5G network, Magma. And then beyond that, we're going to start implementing some of the 5G slicing specification as we move forward beyond those goals. Now, we do have a preliminary commitment to deploy some of this early for a large demo, but the intent for publication of the 5G slicing is in the first half of 2022. And Suresh and Parthiban are going to be doing a demo of our current status and what we're able to deliver today. And we'll talk a little bit about the actual publication of the alpha release of our 5G platform. So that's all I had. And I know we're pressing our time, our agenda time schedule a little bit. So I'm going to stop sharing now and hand it off to Suresh and Parthiban for our status update.
Thank you, Phil. Top notch. Suresh, Parthiban, do you want me to share the screen slides, or do you want to take it away? Can you guys hear us?
That it's good you could share the screen. Suresh can get started from there.
Sure, I'll go ahead and do that. All right. Take it away, Suresh. Hello, Suresh, can you hear us? Apologies.
Yeah.
Yeah.
So sorry. Yeah.
So yeah, go ahead. Take it away, Suresh, please.
Okay. Yeah, currently in Magma master branch in GitHub, the 5G code is committed for the following features: the registration and deregistration of the UE, and then PD session establishment and release, then idle mode support and paging, and then as such, the authentication code of 4G is extended and 5G basic authentication is supported now. And the code is available for experimentation. And in case you need any help as part of the support activity, you can reach out to the Slack channel of Magma. And yeah, towards the end, after the demo, you'll have information about how to reach this support channel.
Thank you.
Kader, can we go to the next one?
Yeah.
So the brief demo scenario is here, and the AGW in the middle, the architectural approach that Magma has adopted. Phil has given a detailed account of it. The elegance of Magma you can observe in the XAP XNAS, means the access protocol, whether it is S1AP of 4G or NGAP of 5G. So that is the application protocol for the access side, and then the NAS, 4G NAS and 5G NAS termination happen in the front. And in Magma today, the daemon is named MME. Eventually, that is going to be renamed to access daemon. This is the only generation-specific network function we have in the 5G or 4G core together in the converged core system. Except for this, all other network functions that are showing up in red color, these are all generation neutral, and Magma have evolved them with an optimized approach. In some other conferences, we have given how Magma differentiates from the 3GPP and what are the optimizations that Magma community have brought in. You can browse through those videos on the YouTube. The subscriber DB handles the addition of the subscribers, and then the QoS policies are part of the policy DB. Session D handles the equivalent of SMF functionality. Of course, it will also handle the 4G related session management. And pipeline D is the control function of the first path. And the orchestrator is going to configure the subscribers on the subscriber DB. And the N1, N2 procedures today that are part of the demonstration are NG setup, the N2 procedure, and then the UE registration, video session establishment, idle mode, support and paging. If time permits, we'll demonstrate, otherwise we'll skip that and directly dive on to video session release and UE registration. With that, I hand over the control to Yogesh and Parthiban to take us into the demo scenarios.
Sure.
It will be a live demo.
Thanks, Suresh. Before Yogesh and Parthiban takes over, I just wanted to mention a couple of things. As you know, one of the objective of this meeting is to really enable the support to the communities, both the third-party communities as well as the vendor and operators community who wants to get support from Magma 5G community. So what we have done is in our Slack channel, we have created a channel, separate channel where you can come in and ask your questions. We'll be happy to support you to do, whether it is a demo or integration with your equipments and so on. We'll be glad to support from the Magma community. And the second thing that I also would like to say here is that we have a Magma orchestrator deployed in AWS, so you don't have to really do the heavy lifting. If you wanted to really test Magma Access Gateway, you can deploy it in any of the hardware that you choose to, right? Commercial off-the-shelf hardwares or AWS Outpost or any other hardware. And reach out to us in the support channel. We'll be happy to get you hooked up to the orchestrator that's available in AWS to have you get started with your trial run and experiment and so on. I also would like to thank here Rebecca, who has really helped us with their 5G simulators to do some initial testings in this deployment, so we are able to better support the community, as well as thanks to Wave Labs for the orchestrator that's made available to the community for support and test of 5G access gateway. So with that, I would like to hand over again back to you, Suresh, and your team to show the demo, please.
Yes, Kaza, thanks. Yeah, Yogesh and Parthiban, without loss of time, let's dive on to the demo.
So Suresh, thanks. Maybe Parthiban, I can just show the demo use case and then start from there. Yeah, so Parthiban, are you able to see my slide?
Yes, go ahead, Yogesh.
Sure, thanks. Hello everyone. So this is just a layout of the demo environment. Here we are having the orchestrator, which is there in AWS, and that is connected to the AGW where the Magma services are running. And we have a GNB and the UE simulator, which is going to connect to the AGW register and then finally establishing the video and connecting to the DNN for sending the traffic. So this is the layout. Rupa, can you please share your screen for the demo?
Yogesh, can you stop your screen sharing?
Sure. Over to you, Rupa.
Yeah. So, yeah, good. We are able to see the terminal here now. So hello, everybody. So Rupa, you have listed down the list of subscribers available right now on the Access Gateway. So this is a couple of subscribers we have added right now for the testing purpose. We will be adding a new subscriber right now through the orchestrator, which is available on our AWS cloud. Yeah, we can move to the NMS dashboard. Yeah. We'll be adding a new subscriber here, and we will be able to initiate a UE call, the registration call, the 5G registration call. So we will be adding the IMSI details with the authentication key and the OPC values. Yes, we will be able to see that now. Save and add subscriber. Yeah, we could see that successfully this subscriber is added here. We could see that this is the last entry available here. Yeah, we can go back to the AGW subscriber CLI. We can list it now. We'll be able to see that. Yeah, we can see the second entry on the list. We have been able to add the subscriber here now. We are able to see it in the subscriber DB. Yeah, Rupa, move to the multi-screen. We could get started with the UE registration.
Yeah. So I think setting up the Wireshark to have the live captures of the registration and the traffic. Yeah. Just giving a brief on the windows here. The top left window, it is at the and the right window, it is the incoming and the outgoing tables, which is part of the OVS. So all the packets, uplink and downlink, they are going to land on table 0, and the packet will be put on the wire table 20. And on the down windows, the bottommost right, this is the GNB simulator, which is going to connect to the Magma 5G core. And on the bottommost left, we have the UE simulator, which is going to register and send the traffic using the Magma core. So Rupa, I think we can start with the GNB connection. Yeah. Yeah, as we can see, the NG setup is up. The GNB is connected to 5G core, and we are good to register our UE and send some traffic. Yeah, Rupa, we can start our UE simulator. Yeah, so we have done the UE simulator. The UE is registered, and we can see the video session is also established. On the OVS table 0, we can see the OVS table is populated with the entries to handle the traffic. The first entry is for the uplink traffic. So this is where the uplink traffic will come with the tunnel ID. In this case, it is some big number, we can say. And so here the packet will come and all the QoS policies will be applied. The GTP packet header will be stripped off and will put on the wire. And the second entry is for the downlink, the traffic which is coming from the internet, basically targeted for the UE. Here we have the UE IP as 192.168.128.21. So we can see our table 0 is ready to serve the UE. Rupa, can we start sharing the sending the traffic, because the PDU is already established? Yeah. So we are sending the simple ICMP packet, and we can see the packets are sent and sealed. It's successful. We can also see the packet counters that's getting incremented. In the first entry, I think yeah, I think there is some display issue. Yeah, it's taking some time. Yeah, so basically we have sent 10 packets, and you can see the 10 packets are sent and 10 packets are received, both in the uplink and the downlink direction, as this is the incoming table. And then moving on to the outgoing table, I think, yeah, it's still loading. Yeah, maybe there is a delay. But the idea is to show that yeah, the packet is actually put on the wire in both the directions. Yeah, no problem, Rupa. I think we can show the PCAPs. Maybe we can, or you. Yeah, or yeah. So this is the PCAP where we can see the registration request going through, and we can see that there are some sync failure, but that is recovered, and we have sent the authentication back again. And after the security mode complete, the uplink and the downlink packets are sent with the GTP header. So this is the signaling part, and then we have the request and the response part. And yeah, you can see all the packets here. Yeah, Rupa, I think shall we do a session release and deregister? Yeah, so here we have done the session release. The video session is released. So we can see the video has been, the session has been released successfully. Okay, yeah, I think the window is taking some time to load. Yeah, I think we can start the deregistration procedure. Yeah, and now the deregistration is successful. The UE has been successfully deregistered, and all the OVS tables which were present, the additional entries for handling the traffic is being removed. Whatever is left over is the default entries which are present. Yeah, Rupa, maybe I think we can just go back to the PCAP and just see the packets for. Yeah, so here we have, after the traffic has been sent, we can see the video release message, the video session release message, and then in somewhere in the down, Rupa, I think we can go to the down and we can focus on the deregistration. Yeah, so here we have both the video session release and the deregistration happening. Yeah, so I think I would say this was our demo. I think for idle mode and paging, it will take some more time. So I think we will just stop here.
Yeah, thank you, Yogesh. Thanks a lot, Suresh, Parthiban, Yogesh, and the team. Normally, my experience has always been demo when it has to work, especially the live demo doesn't work, but it's awesome to see it work today. Just wanted to make sure that I say this again. We have a dedicated support channel in the Magma community. Those who wants to try it out, as you saw today in the session, feel free to reach out, as well as feel free to reach out if you wanted to have your access gateway connected to the orchestrator that is out there. And it's pretty much free, right? Just to make sure that you get started quickly and get your experiments and hands-on into working 5G call flows and so on. So that brings us to the end of this session. Q&A, Phil, and I are here. Please feel free to unmute and ask questions, or feel free to send your questions on the chat. I will answer as many as we can. And if you are not able to, because of the time constraint, you know where to reach us in the Slack channel of the Magma community. So Phil, there was a question. I know that you kind of answered it. So the question was more about from Bhavin. Hey Bhavin, hope you're doing well. Does Magma currently support IMS network? So if you want to answer that, Phil, for the benefit of everyone else, please feel free to.
Yeah, the question in the chat, and you can see it there, was, will we be supporting IMS services on the 5G deployment or with Magma? And Magma in 4G has been successfully tested and has a deployment in place that where the end user is offering IMS services. It's actually currently in test, but it is working with IMS voice services. That end user did that testing themselves and contracted some support for that back to the Facebook Magma team, but they did that contracting under NDA, so I can't disclose all of the details of what they tested with, but it is a Metaswitch-based IMS deployment that at a very high level. For the 5G case, there's one blocking feature that is in our Q3 deployment, which is network initiated QoS. Once that is available, there's no functional reason that voice over NR couldn't be implemented with Magma handling the voice core, although we don't have any current plans in place to actively test that or any user demand for that testing today.
Thank you, Phil. There is a question from Steve Warwick, and he wants to understand the current and planned support for mobility.
Yeah. Right now in our current feature set that we've got folks actively tracking development on, the mobility features are not currently prioritized. I think when we talked about how Magma chooses what features to implement, it was noted that they're driven by demand signals coming from active deployments, not speculative demand. So there's our prioritization of the mobility features would actually be tied to, discussions with an end user who would want to actually deploy a service that includes mobility.
Thank you, Phil. Check some other questions here. So this question is from Pratik Das. Is Magma throughput basically constrained by the vSwitch capabilities? Suresh, Phil, anyone in the call want to take this question?
Yes, Kader. As such, it's not constrained by OVS as such. The evolutionary journey of Magma is that we want to realize the functionality, and there is a certain set of end user cases for which the product is targeted. Over time, we'll have the accelerators and the SmartNICs integrated into any hardware, wherein this line rate requirements to provide the user space networking requirements for the production grade systems also will be part of the Magma.
Thank you. There is a question from Samir Rayani. So he is asking, how do you test Magma? Is it using some kind of simulators? So I know that we use number of different types of simulators. Phil, Suresh, do you want to take that question and answer?
Sure, Kader. As part of our development effort, we are using UERAN sim and SRS simulator. And as part of integration of the Magma network functions, we are using DS tester and TeraVM. And for scale tests, today we have a goal towards the end of this quarter. We want to realize 600 UEs connected to the core, and they're connected via 12 GNBs, and one policy and one session per UE. And the uplink, downlink, aggregate throughput put together, we want to realize up to 600 Mbps. So today in the market, our observation is no single simulator is comprehensive enough to cater to the complete conformance towards the standards. So that's the reason we are using multiple simulators.
Sorry, this is Samir. So how do you do multiple simulators in the sense that you have like a dozen UERAN sims and a dozen SRS, or I didn't get that part.
Yeah. The developer setups are with the individual developers or their own labs in their communities. And they use the UERAN sim or SRS simulator in those environments. And Rajesh, who initially was sharing the vision, he also has in one of the developer conferences walked us through videos. And in fact, you can also reach us on the Slack. Basically, there is a lab dedicated in Facebook Labs, wherein the DS tester is part of the lab. I can't give the exact name of the lab for confidentiality reasons. And there is one more lab set up where TerraVM and Spirent are part of the test beds. So there are independent test beds where we test the features and make sure that we get green light out of each test bed. Eventually, we take it to the real UE, real GNB setup. So this is a step-by-step process we're going through now.
Thank you very much.
Thank
Really
you,
appreciate
Rajesh. And recently Rebecca is also helping us in the community to leverage their simulators to test. So it's getting tested with multiple simulators, which eventually hardens the stability of the product and features and functionality of the product that it is intended to work. So there's another question. This question is coming from Brian Callaghan. So he's basically asking how much would it cost to deploy 5G and provide coverage, intending to work with Freedom 5 and get a Helium gateway to deploy coverage on remote location islands. I just wanted to check here, is anyone from the community, Freedom 5 in the community today in the call to answer that? Okay, anyone from Freedom 5? No. So Brian, I mean, in the Slack channel, there is a Freedom 5 dedicated Slack place where you can actually go and ask this question. I'll also make sure that this question is passed on to the friends and they are able to get back to you. So the next one is, I joined late. How can I access recording of this meeting? So we will put this in Magma community YouTube channel, and we will also figure out the way how to get the presentation to all of your hands. Phil, do you want to comment a little bit on that? The way that we can, yeah.
We will announce the video on the Slack when it's published. It's going to need some post-processing by LF just to make it distributable, and we'll get an announcement out on that.
Great. So we are 1 minute above the scheduled time, but we do have a couple of questions. Let's quickly take them, and rest we will address it in the support channel. Do you have N4 interface implemented between the control plane and UPF, which would give the option of using any UPF? This question is coming from Jacob. Phil?
Yeah, I answered that on the chat. Right now, we expose N1, N2, N3, and N9, presenting a unified access gateway. We don't expose N4, so doing a third-party UPF attached to Magma is not possible at this time, although there have been discussions along the way being driven by our work that we do with the TIP Foundation that has talked about how we might do that, but right now it's not part of the product.
Thank you, Phil. And there are questions from Jose Neilhoff. With the interest of time, we apologize not being able to address your questions. But what I recommend is please, download. You all are probably using Slack, and please join the Magma Slack channel and reach out to the community. We'll be happy to support you to answer all the questions that you have posted, and also the questions that you may have in your mind to ask. So with that, Phil, I'm going to give you the honor to close the session, and we'll go from there.
Yeah, thanks everyone for coming. We're super excited about what's going on with the Magma program and to see the level of interest that brief talks like this generate. So thanks for joining us. And again, the best way to communicate with the Magma team is via our Magma Slack channel, which is quite active with over 2,000 members and over 100 of them daily active. So please join us there.
Thank you, everyone, and thanks for joining. See you in our next monthly meeting, second week of September, Friday, same time. Take care. You all have a wonderful day as well as wonderful weekend. Bye-bye.
Thank you.
Thank you.
Thanks. Bye.
Thanks, bye.